Welcome to ePathshala Architecture lecture series for AMARC students. In this module, we are going to see the various types of solar systems and solar system, the design and various types of materials used in solar PV systems. And the learning objectives are PV technologies and PV system design and applications. The various types of solar cells, that is a first generation solar cell, single or monocrystalline solar cell, and the multicrystal solar cell. And the single or monocrystalline solar cell will have high efficiency when compared with the multicrystal solar cell. But commercially, the multicrystalline solar cells are being used because it is cheaper than the single monocrystalline solar cell. And the multicrystalline or the other cells, and it is really coming up in the market, and particularly the first generation cells are really quite matured, and there are opportunities to enhance the efficiency of the solar cell. And the second generation solar cells are ASI, that is amorphous silicon thin film solar cells, and CdTe cadmium telluride solar cells, and CIS copper indium gallium, and CIGS copper indium gallium selenide solar cells. And third generation solar cells like nanocrystal based solar cell, polymer based solar cell, and dye sensitized solar cell, concentrated solar cell. And people do a lot of research in solar cell to enhance the cell's efficiency, but currently the cell's efficiency is in the order of 15%. It is quite low when compared with other conventional power plants. That is why the scientists and engineers are keep working to improve the performance of the solar cell. Currently, the multicrystalline solar cells are being used in the market, and this is the structure of monocrystalline silicon cell. So, the monocrystalline silicon cell looks like this, and when you see this structure, and by seeing the structure of the solar cell, you can name it monocrystalline silicon cell. There are these are made using cells sliced from a single cylindrical crystal of silicon. This is the most efficient photovoltaic technology, and converting around 15% of sun's energy into electricity. The efficiency in the order of 15% for monocrystalline solar silicon cell. Of course, it is a little bit expensive when compared with multicrystalline solar cell, and this is about multicrystalline or polycrystalline, both are same polycrystalline solar silicon cell. This will appear like this. This is the structure of the polycrystalline or multicrystalline solar cell. It is also known as multicrystalline solar cells, and these are made from cells cut from an ingot of melted and recrystallized silicon. They are generally cheaper to produce than monocrystalline solar cells and slightly less efficient with average efficiencies of around 12%. Polycrystalline solar cell or multicrystalline solar cells are commercialized nowadays because it is cheaper than monocrystalline solar cell. And this is amorphous silicon cell, and it is quite flexible, and that is amorphous silicon cells are made by depositing silicon in a thin homogeneous layer onto a substrate. The cells can be thinner, hence it is called thin film photovoltaic cell, and it is quite flexible, but the efficiency is in the order of 10%, and when compared with monocrystalline and multicrystalline, it is giving very less efficiency, but then it is cheaper than other two cells. And this is about the various semiconductor materials in use in the solar photovoltaic technologies, and this is the band gap, and this is the efficiency. And here you are seeing that various semiconductor materials like GE, germanium, Si, that is the silicon, and GaAs, that is gallium arsenide, and CdTe, that is cadmium telluride. And here the atmospheric temperature may be in the order of 25 degrees Celsius, and here the cadmium telluride, which is giving around 25% efficiency, and then followed by gallium arsenic, it is giving around 23 to 24% efficiencies, and Si, that is the silicon cell, it is giving efficiency in the order of 20%, and GE, that is very low, which gives about 10% efficiency. This is about the typical solar PV system at home, and this is about the solar PV panel, which is installed at the rooftop, and so which may be a multi-crystalline solar cell, and so that is being commercially used nowadays. And from the solar panel, electricity is generated, and of course you have the solar PV system circuit. It is there is charge controller, and this is the battery. The charge controller helps the battery for charging. It avoids less charge or higher in charge, and these are the loads, and the electricity is being used for the lighting at home, and for the TV operation, the fans can be utilized, or these are all gadgets which consumes less electricity, like TV or computer, the laptop, or lighting, the lights and fans. Whichever gadgets are consuming less electricity, definitely we can go for solar photovoltaic technology, and it is fixed at the top of the roof. And there is one concept, it is coming everywhere. They put a net metering, and so at home we can have this solar photovoltaic panel, and we can generate electricity, and we can consume whatever we generate. If we generate excessively and more than our consumption, then it can be fed to the grid, and the electricity board will pay for it. That is the net metering, and so we can use for our home purposes, as well as when we generate extra electricity, it can be fed to the grid, and we can get money out of it. This is about the solar PV dependencies, and so here the location, and when we want to install the solar PV system, so the location is very, very important, and so the latitude, the lower latitudes better than the higher latitudes, and according to the latitude, and the system is inclined according to the latitude angle. For example, in Chennai, the latitude is about 13 degrees. All the solar devices, solar photovoltaic system or water heater, whatever it is inclined according to the angle of latitude. So that, and it gets solar energy in the maximum time of the day, and the weather, the clear sunny skies better than the cloudy skies. Temperature is not important here, and the temperature is needed for heat application, that is so solar thermal applications, and there the heat energy is utilized. In the solar photovoltaic application, it accepts only the radiation, not the heat. Heat is not at all important, and if the intensity of the radiation is quite good, it is fine. And that is why in hilly areas, particularly in Kashmir and Switzerland, and it has a very clear sky, sunny skies, and in Ladakh also, and very clear sunny skies, and the radiation is good, and but temperature is not there, but then it is no problem, and with the radiation is good, and then definitely we can go for a solar photovoltaic system. And the direction solar arrays face, the south preferred, east and west acceptable, and this is most important. So all solar energy gadgets, solar photovoltaic system or solar water heating system, it should face south direction, because our country is located in the northern hemisphere, and that is why the solar system should be facing south. And if the country is located in southern hemisphere, then their solar systems should face the north. For example, the Australia is located in the southern hemisphere, their system should face northern hemisphere, so that and it gets solar radiation most of the day. And absence of shade, and there should not be any trees near the solar photovoltaic system, okay. And flat terrains, like and it need not be ups and down locations, and moderate temperature affects the output power. And so this is solar PV dependency, and the latitude should be maintained according to the site's latitude. The solar system has to be inclined, and the weather condition, and it should have a clear sunny sky, and the temperature is not important, and intensity of radiation is important, and the direction, and the south facing should be there all the time, and the north facing should be avoided, and east and west is acceptable. And these are the three factors for the location. Systems installed must have southern exposures, and for maximum daily power output. The southern exposure must be free of obstructions like the trees, mountains and buildings that might shade the modules summer and winter paths of the sun. And the systems must also have appropriate terrain and sufficient space to install the PV system. And around the PV system, and you have to have the free space, so that the shade can be avoided. And the system should face the south direction, and it has to kept according to the altitude, the latitude of the earth. And in Chennai, about 13 degrees inclination is necessary. And this is, and before we installed a solar photovoltaic system, and we have seen and what location has to be selected, and in the location the solar intensity is necessary, and the system should have should face south direction, and it has to kept according to the latitude angle. And to find out all these things, and there are stations. So this is the typical solar radiation resource assessment, solar radiation resource assessment station, and it is located in NIWE, National Institute of Wind Energy, which is in Chennai, and it is coming under Ministry of New and Renewable Energy. And these kind of stations are located in many parts of the country, and many states and many districts and many taluks and many institutions, and this kind of solar radiation resource assessment stations are installed in plenty, and all readings will come to the central place, that is National Institute of Wind Energy. In the national hub it will come and stored there. And so, and the NIWE is providing meteorological data for each and every location in the country. And if you want to say put your solar PV system, and you can say browse and find out, so what is the meteorological data available at that particular location, and accordingly you can choose the location. And these stations are very helpful, and these stations will measure all meteorological data, and it will give it to the national hub, and from there and we can tap. And before we install, we should check all these meteorological data. And this station is a typical station, and here you face this is the lightning arrestor tower Of course, upon this system there should not, the lightning should not affect. That is why around near the system we have to put a lightning arrestor tower. And this is about the wind mast, which is about 6 meters height, and here you find the solar tracker at 1.5 meter height. And here there is a pyrheliometer and pyranometer, and pyrheliometer will measure the direct radiation at that location, and pyranometer will measure the global radiation at that particular location. And you can put the shade upon the direct radiation, and you can measure diffused radiation also. And to give the energy to this pyrheliometer and pyranometer and that wind mast, and here there is small solar PV panel is installed. The power is given to this meteorological station, and there may be power cut in between, even in the day, and that time, and through the solar PV panel the electricity is generated and it is stored in the battery. The necessary electricity is given to the meteorological station, and this is rain gauge, and the rain also measured here through the rain gauge. And here, and this kind of stations are installed in many places in the country. This kind of station is very useful to obtain the necessary data. By looking at the data, we can choose the appropriate location before we install the solar photovoltaic system. And this is the site photographs, and this is about pyrheliometer and pyranometer, and this is kept it in the tower, and this is the display, and about the spec of that particular specification of the particular station. And here there is small solar photovoltaic panel which generates electricity, and it is stored in the battery. It is given to the system. So, and it is in continuous operation without any break, though the power cut exists. And again, this is the meteorological tower, and here the GPRS antenna is given, ultrasonic wind sensor is there, GPS is there, and the temperature measurement and relative humidity sensor is also there, rain gauge is there, and data logger is there, and the battery and barometer is here. So, and the GPS and GPS RS antenna and ultrasonic wind sensor, the temperature measurement and relative humidity measurement, everything is taken and it is stored in the data logging system. And for solar photovoltaic system, and here the intensity of radiation is also measured through pyrheliometer and pyranometer, and it is stored in the data logging system. Here you see the solar tower again, and here you see the shaded pyranometer for measuring diffused radiation, diffused horizontal irradiance, DHI. It can be measured by putting a shade on the pyranometer. And this is the pyrheliometer. You can take a direct radiation, direct or beam radiation, a normal radiation, and here the shading disc assembly, and you can operate this, and you can take a measurement for diffused radiation, and this pyranometer will give directly the global radiation also. And this is the solar tracker. So, the complete system moves according to the sun's path, and this is about 1.5 meter height, that is solar tower. And this is the typical solar tower. It is installed at various parts of the country, and to get direct radiation, diffused radiation and global radiation, and temperature and everything will be taken, and it will be sent to the national hub. And this is about the dedicated solar radiation resource assessment stations in the country. Phase 1, initially 51 stations were created. Phase 2, again 60 stations were created, and MEDA that is slightly advanced level stations, 4 have been created. AMS, again another further advanced meteorological stations, again 4 were created. Totally we have 121 stations in the country. All this mark, it represents the solar radiation resource assessment station in almost, it is covering entire country from Kashmir to Tamil Nadu and the western east side. So, everywhere, and these meteorological, that this solar radiation resource assessment stations are installed, and through which we can obtain the data, and before we install the system, we have to check the data available. And this is about solar PV array design and tracking. Array design, array flat panel, it remains in a constant fixed position, and array tilt equal to latitude, it is the best one. Increase solar radiation by 10 to 20% compared to 0% tilt. Sunnier locations benefit more, and array azimuth angle, that is 180 degrees, that is the best one, directly south. And here the solar PV is fixed constant, and if we maintain equal to latitude angle, when it is tilted, when the array is tilted, then 10 to 20% improvement is there in the performance, and also it should face directly south, so that the performance could be further improved. And apart from fixed type solar PV power plant, and then we can also have tracking system. This is array single axis tracking, tracks sun across the sky during each day and stays at a constant tilt, and increase solar radiation by 25 to 30% compared to no tracking, and sunnier locations benefit more. And when you have the tracking system like this, so the entire the solar photovoltaic device, the system can be tracked according to the sun's path, and because of that 25 to 30% performance could be improved from which the system is fixed. And this is array 2 axis tracking, tracks sun across the sky during each day, adjust tilt more in winter and less in summer, increase solar radiation by 33 to 38%, sunnier locations benefit more. And when compared with single axis, when you go for 2 axis system, again the performance of the system is increased from in the order of 33 to 38%. And so far we have seen about solar photovoltaic dependencies, and now we are going to see about the design of solar photovoltaic system. Before that, we can look at the cost. Here the PV panel rating, it is given say a 10 watt panel, it is about 500 rupees, 20 watt panel about 1000 rupees, 40 watt panel it is about 2000 rupees, 75 watt panel is 3750. Normally the solar PV panel is in the order of 10 watt, 20 watt, 40 watt and 75 watt, 100 watt, it is like that. The costing is it varies from 10 watt to 75 wattage, and when the wattage increases, the cost will also increase. And per watt it is about 50 rupees. Now the current cost has come down, and even 20 to 25 rupees it is available, but the supreme cell, it is costing about 50 rupees per watt, like the European cells are little bit costlier, and which is costing about 50 rupees per watt. And this is the typical cost of the batteries, and here we have battery rating in ampere hour, and 40 amperes battery, 60, 90 and 110 and 150, and this is the voltage rating about 12 volt batteries, and this cost, this is about 40 ampere hour battery is about 3,300, it varies, and then it reaches about 9,500 when it is about 150 ampere hour. So, we can choose the battery according to our need. And this is the spec of an inverter. The inverter is necessary. So, whatever electricity we are converting from solar PV panel is direct current, it is DC current. And at home we cannot use DC current, and we have to convert that into AC current. Here the inverter plays a vital role to convert DC current into AC current at home, and that is why the inverter is necessary. And the solar photovoltaic system, other than apart from panel and battery or charge controller, inverter is necessary to convert DC into AC. And here that is about the rated, that is input output, and the power, voltage, and frequency and waveform, and it is available 1000 VA to 3000 VA, and this is 5 kVA to 8 kVA and 9 kVA to 15 kVA, and the voltage is normally at about 12 volt to 24 voltage, and 220 voltage to even 110 voltage is also available. The frequency, it is in the order of 50 hertz, and waveform full sine wave, and this is about the spec of the inverter. And this is the typical cost of the inverter. If you want to go for 1 kVA inverter, it is about 5,000, 2 kVA 7,000, 3 kVA and 9,000, and 4 kVA it is about 12,000, and 5 kVA it is about 15,000. So, according to our need we can choose the right kind of inverter. And this is about the typical power ratings of common appliances, and so we can use CFL lamp, and it is in the order of 8 to 18 wattage, and fans, the wattage is around 60, and tube light and copper choke, it is about 55 wattage, and tube plus electronic choke, that is about 47 wattage. So, this is about wattage of home appliances. And so, the summary, and so far we have seen the different types of solar photovoltaic cells, and monocrystalline cell, and polycrystalline cell, and monocrystalline cell is giving better efficiency. The multicrystalline or polycrystalline, though it gives lesser efficiency when compared with monocrystalline, and it is cheaper in cost. So, the multicrystalline is being widely used in the country, it is already well commercialized. And apart from that, the thin film, and wherever the flexibility is necessary, and it can be rolled in your hand, you can, like mat, it can be rolled, and you can take it, and wherever you want to have electricity, suppose if the cell phone has to be charged or any gadgets to be charged, and then you can just spread the thin film, and you can just leave it under the sun, and once it is charged, and then you can utilize it. That is the thin film, it is very flexible, and you can carry wherever you go, and even for the mountain climbing, and in the bag you can have the solar PV in the thin film, so that your gadgets can be charged, and wherever we travel, and we can take that thin film solar cell, it is very flexible. And then we discussed about the solar PV system dependencies, and this is most important, the selecting of location most important, and so the all solar systems, PV or any solar thermal system, it should face south direction, so that you can get much efficiency, and so not only that, it has to be tilted according to the latitude, and in Chennai it is about 13° latitude. Our solar photovoltaic system should be tilted to 13°, and it should face always south direction. and for which this SRRA stations are very helpful, that is solar radiation resource assessment stations. 121 stations are installed across the country, and there are lot of stations in the state of Tamil Nadu. All over the country it is being located, and the one station data could cover about 50 kilometers radius and sometime even 100 kilometers radius, and so that data is applicable, and so we can measure, we can see the yearly data past couple of years, what is the solar intensity, maybe the temperature, relative humidity and wind velocity. Everything can be assessed, and then accordingly we can plan to install the solar photovoltaic system. And this station, it has a pyroliometer and pyranometer, and by which you can measure say direct radiation and diffuse radiation and global radiation. Of course, temperature sensors also available to measure the temperature, and the rainfall also can be measured through the rain gauge, and the wind velocity also can be measured by the anemometer. And these stations are located at many parts of the country, and the facilities there in the NIWE website, National Institute of Wind Energy, and there it can be browsed, and for the particular site, and all meteorological data can be taken. And then we discussed about the solar PV array and tracking, and by single axis tracking or double axis tracking, and definitely we can improve the performance of the system. And instead of fixed system, when we go for single axis tracking or double axis tracking, we can improve the performance. And then we have seen the typical cost of the PV system, and the PV module cost, it is decreasing and decreasing year by year. About 10 years back it was 200 rupees per wattage, and then before 5 years it became 100 rupees per watt, and then couple of years before it was 50 rupees per watt. Now it is 20 rupees per watt, and for the good PV cell, European PV cell, again it is 50 rupees per wattage. And so we can assess the cost of other components in the PV system. It is not only the solar module, it needs inverter to say transfer the DC into AC. We should have the inverter, and then there should be battery and charge controller, and so that we can have continuous power supply for our gadgets. So we have to identify what is the cost of the battery and the inverter and the PV modules, so that we can plan to install the solar photovoltaic system at our rooftop. And so I mean with this I stop this lecture. Thank you for listening.